All right, to finish up our absolute value chapter, we are looking at kind of putting together the techniques that we learned to solve inequalities and to solve absolute value problems and putting them together in the same type of problem. So as a reminder, when you're solving inequalities with absolute value, keep in mind all of your definitions for absolute value. So we should be getting out solutions for an absolute value that are greater than or equal to 0. Otherwise, it goes against our definition. But keeping that in mind too, anything that you plug into an absolute value function, again, you'll always get returned that positive answer, and you could plug in positive numbers and negative numbers and still get out a valid absolute value solution. So we have to consider all these possibilities when we're setting up these equations. So if you have something that looks like absolute value of x is greater than n, the two inequalities that are going to help look at both of those cases, we would write x is greater than n, and then our second version for our equation would be x is less than negative n. So kind of like when we solved absolute value equations, we did the positive version, we did the negative version. Well, when we do that with inequalities, the kicker is we're multiplying that n value, or whatever number we have, we're multiplying it by a -1. And anytime when you're dealing with inequalities, multiplying or dividing by a -1 means you have to switch the direction of your inequality. Okay, and our second one, given that our absolute value of x is less than n, our two inequalities would look like x is less than n. Again, no change in our signs. But then when I change the sign on my n, means I also have to change the direction of my inequality. So let's see what this looks like. Again, we're going to start out pretty straightforward with just an absolute value compared to a number. So in our first one, absolute value of x is greater than or equal to 3. So our two versions would be x is greater than or equal to 3, and x is less than or equal to -3. So we don't actually have to do any solving for this one, so let's just graph this out. So we have x is greater than or equal to 3, which means we're going to include the 3, so a filled in circle, and everything greater than. Okay, x is less than or equal to -3, again, filled in circle, everything less than. So this is just like one of our or inequalities that we were looking at before. We need to mention both of these sections when we mention our solution set. And typically when we're listing things out in math, we typically start with the smallest number first. So I would list this out as x is less than or equal to -3, or x is greater than or equal to +3. And it's kind of the number order you have on the number line as well. So may as well stick with it. Okay, example 2. So now we're looking at x, our absolute value of x is less than 3, so our two versions. And first one, we don't change our order at all. Second one, we're changing it to a -3, so that means we flip the direction of our inequality. So x is greater than -3. Again, no need to solve anything out. We already have x by itself. So x is less than 3 means we have an open circle, and we're shading below the 3. X is greater than -3, so open circle, shading above, and we actually have our sections overlapping in the middle. So this isn't one of the scenarios where we're going to say, hey, well, I can have everything from this and everything from this. So let's actually pick a number, plug it in, see what happens with us checking out our work. So I'm going to choose a number that's outside of kind of where these two solutions are joined. So let's pick +4 and see what happens when we plug that into our original expression. So for our check, I'm going to do absolute value of 4 less than 3. And lo and behold, absolute value of 4 is just 4. And 4 is not less than 3. So I pick something outside of that overlap, it doesn't work. So all I care about is the fact that our solutions are going to be sandwiched in between the -3 and the +3. So our solution set looks like -3 is less than x is less than 3. Okay, now let's look at one that's starting to kind of bump it up a little bit. Now we have an expression in example 3. So in example 3, we have absolute value of x minus 1 is greater than 3. Okay, so let's see what's going on. So positive version, and x minus 1 is less than negative 3 for our negative version. In each one, we have to add 1 to both sides. So x is greater than 4, and x is less than negative 2. So again, let's see where these are happening on the graph. So x is greater than 4. Again, no equal sign, so we have an open circle, and we're going above 4. We have x is less than negative 2. Again, open circle, less than 2. And again, we don't have any overlapping sections, so we could pick either one section or the other. But if we were to go through and check, if we pick something like the 0 in the middle, when we fill that into our absolute value equation that we started with, everything falls apart. We do not have a valid solution. Okay, so that means the only things that work are the two different sections. So again, I like to write them in number order. So x is less than negative 2, or x is greater than 4. Okay, number 4. The only thing that's changing is where the direction of the inequality is going. So what do you think is going to happen with our solution? Well, let's see. So again, two different versions. So x minus 1 is less than 3, and x minus 1 is greater than negative 3. Again, flip the sign around every time you multiply that right-hand side by a negative. Okay, add a 1, so x is less than 4, and x is less than negative 2. Excuse me. Greater than. I'm not multiplying or dividing by a negative, so I don't need to change my inequality. Okay, we have x is less than 4, again, open circle, but this time we're shading to the left. And then we have x is greater than negative 2, shading to the right. So this is where we have our overlap happening in the middle. And again, if you want to, if you're not quite sure if you have the right solution, excuse me, pick a number outside what you think is the solution, see if it makes your equation fall apart. So let's test one on this. So I'm going to pick 5 because he's sitting outside our solution. So for my check, 5 minus 1, absolute value is less than 3. So absolute value of 4 would be less than 3. 4 is definitely not less than 3, so yep, we shouldn't have any solution in that area. So we are good to go. So our solution set, we are sandwiched in between 2 and 4. Okay, example 5. All I changed was the inequality. So what's the only thing that's going to change in this problem? Yeah, everything else should be the same, except I should have some filled in points instead of the open points. So just double checking. Again, x minus 1 is less than or equal to 3. My other version, x minus 1 is greater than or equal to negative 3. So then solve them out. Add a 1 to both sides, so x is less than or equal to 4. X is greater than or equal to negative 2. And again, the only difference is having that equal bar, so everything has a filled in circle. I'm not even going to bother to test this one out like we did in the last problem. Because again, if all I'm changing is the inequality symbol, but I still have an inequality, everything's still going to really behave the same way. So we're sandwiched in between negative 2 and 4, but this time we're including those values. So we have the equals. So how do we know to compare this back to what we talked about? How do we know if we have an and inequality versus an or inequality? Well, it really just depends on what's coming up on the graph. So your and inequality when you happen to have those sandwiched in between each other, your or when they just end up going in the opposite directions. Okay, let's try a few more examples. Okay, example 6. Oops, let me save that. There we go. Okay, so actually go ahead and pause the video and try out number 6 on your own, and then come back and see how you did. Okay, so let's check how you did for number 6. So again, we already have our absolute value bars by themselves. So our first task, we're going to write our two versions. So here we go. We don't need our absolute value bars for our two versions. We just need negative 8a minus 3 is greater than 11, and negative 8a minus 3 is less than negative 11. Okay, add a 3 to both sides, so negative 8a is greater than 14. And then divide both sides by negative 8, but when we're dividing by negative, what has to happen? We've got to flip our inequality. So this is going to really be a is less than negative 14 over 8. And I'm going to go ahead and reduce my fraction. I could also, at this point, if I wanted to, actually change this over to a decimal. But since I know I don't really need to plug this in anywhere, I may as well just leave it as my reduced fraction. Okay, right-hand side, follow the same steps. So we start out by adding 3 to both sides. So negative 8 is less than negative 8. Hey. And then divide both sides by negative 8, which means we have to flip our inequality. A is greater than 1. So you'll notice on your number line, I actually didn't leave any labels for you. Really, these are just to help us map out where our solutions are going to happen. So I'm just going to go ahead and label in, I know negative 7/4 is smaller than 1. So I'm just going to put 2 spots on my number line and then just use those to map things out. I have a is less than negative 7/4, so open circle shaded to the left. A is greater than 1, again, open circle shaded to the right. And again, I could absolutely check this out. If you want to know, hey, or did my solution set work, pick something that's in your shaded area and plug that into your original equation. If you want to double check that, hey, the pieces that I don't have shaded in, are those truly not solutions? And check to see if it makes your equation fall apart. So our solution set on this, again, least numbers I usually list first. So I'm going to say a is less than negative 7/4, or a is greater than 1. Okay, example 7, we need to go back to how we solved absolute value problems. So when you're looking at those, what was the first thing that we had to do to solve these out? Keep in mind your 9 that's in front of your absolute value bars. Do not try to do this like distribution. You absolutely want to move the 10 first and then deal with the 9. So again, go ahead, pause the video, try this out just like you were solving an absolute value equation before, and then come back to see how you did. So let's check it out. Okay, so again, we want to move the 10 first. So 9 times the absolute value of m minus 8, add 10 to both sides, so I'm looking at 36. Now I want to deal with the 9, so I'm going to divide 9 out of both sides. That gives me absolute value of m minus 8 is less than 4. And now my absolute value bars are by themselves, so I am ready to solve this equation out. And I need to do my 2 versions. So I have m minus 8 is less than 4, no changes other than getting rid of the absolute value bars. Second equation, m minus 8 greater than negative 4. Again, flip it around because I multiplied by a negative for the 4. Okay, add an 8 to both sides. So m is less than 12. And on our right-hand equation, that means that m is greater than 4. So again, map them out. 4 is the smaller number, so I'm going to put him towards the left. Neither one of these has a filled-in circle because they're either less than or greater than. So we are greater than 4. And we're less than 12. So that means we've got an overlap happening in the middle. So our solution set will be 4 is less than m is less than 12. Alrighty. So again, number 8, what looks a little different about this one? In number 7, we had a leading 9 in front of our absolute value bars. This one, we have a negative 2. So just be careful when you move this one that we still have to take into account that negative value. So I don't have any other constants to move away, just the negative 2 that's sitting outside that absolute value. So if I divide both sides by negative 2, it's going to leave me with a 5x minus 9. But dividing by negative 2, what do I need to do? Flip my inequality. And so now let's see here. Let's consider this answer or this problem that we have so far. So absolute value of 5x minus 9 is greater than or equal to -5. Well, absolutely it should be, because when you take the absolute value of a number, what always happens? You get out a positive answer. So you want to be careful on here. We're still going to get something valid solution-wise, but keep in mind, you always want to be going back to your definition of absolute value. Make sure that it's working with all of your work, with all of your solutions. So two different versions of our equation. We have a 5x minus 9 is greater than or equal to -5. And we have a 5x minus 9 is less than or equal to +5. Add a 9 to both sides. So 5x greater than or equal to 4. Divide both sides by 5. And again, I'm just going to leave this as a fraction. It's reduced as far as it can go. You could write it as a decimal if you really wanted to. Okay, same scenario, same steps. So add a 9 to both sides. So 5x is less than or equal to 14. And divide both sides by 5. So x is less than or equal to 14 divided by 5. Again, reduced, so I'm just going to leave it. 4/5 is definitely smaller than 14/5. So he's going to go towards the left and 14/5 towards the right. If we're looking at greater than or equal to or less than or equal to, what kind of circle, what kind of dot do we need to have? They have to be closed. So if we're doing greater than or equal to 4/5, we have a filled in circle shaded up, and x is less than or equal to 14/5, filled in circle shaded left. And again, if you're worried about your solutions not working, check a few of them, see if they work. Okay, so our solution set, we are sandwiched in between 4/5 and 14/5. So 4/5 is less than or equal to x is less than or equal to 14/5. Okay, go ahead, pause the video and try number 9 on your own. Did you run into any problems? So let's think about what we get when we try to get this by itself. So just like in example 7, we need to move some things around. So the first thing I'm going to do is move that 10. So let's add 10 to both sides. So 9 times absolute value of r minus 2 less than -63. Okay, then I need to move my 9. Okay, so divide both sides by 9. So absolute value of r minus 2 is less than -7. Think about that for a second. My absolute value is less than -7. What happens when you take an absolute value? Yeah, your numbers should actually always come out positive. So this problem actually has no solution. I'm going to keep working it just in case, and I want you to see what's going to happen when we try checking our work. So technically no solution, but let's see what happens. So r minus 2 less than -7, and r minus 2 greater than +7. So I solve this out. So r less than, see, add 2 means less than -5, and r greater than 9. So, I mean, it looks like any other solution that we have, but let's see here. Because we would have going at -5 and +9. And the way they're shaded, we would go less than or greater than. So let's actually check one of these and see if it works. So I'm going to go ahead and check 10. Now, fairly easy number to check. So let's plug that in and see what happens. So 9 times absolute value of 10 minus 2 minus 10 less than -73. Okay, so 10 minus 2 is 8. 9, well, excuse me, absolute value of 8 is just 8. So 9 times 8, 72. And 72 minus 10 is 62. And so this is saying that 62 is less than -73. Well, that's not right. And that was one of the pieces that was actually in our valid solution. Let's try another one just to make sure. So let's pick something from the other group. So let's go -10. So again, let's see if that one works. So 9 times the absolute value of -10 minus 2 minus 10 is less than -73. Okay, so that gives me -12 inside my absolute value. And I'll be honest, I don't have my 12s times tables memorized very easily. I need to have room for other stuff. So absolute value of -12 is just 12. And 9 times 12 gives me 108. Less than -73. Wait a second, I'm running into the same problem. 98 is not less than -73. It doesn't work. So this whole solution is invalid. So this has no solution. And again, save yourself some time. When you see something like this happening, when you have an absolute value that is less than a negative number, right off the bat, you'll know, hey, I can't have a solution for that. But be careful. You can still mathematically get some values out, but as we just proved, yeah, that doesn't mean they're going to work when we plug them back in. So when in doubt, just check your answers and use that to determine, hey, is my solution valid, or do I need to go back and think about my steps a little bit? So go ahead and let me know if you have any questions, as always. And if not, start in on your review stuff or check in with me on Zoom if you get stuck on anything. See you later.